Yeah, my name is Andrey, and I'm glad to see so many people after lunch actually joining my talk. The funny thing is that, this talk has nothing related to Java, even though this is kind of a JVM, Java conference. The only reason I'm giving this talk, I guess, is because I'm actually a Java developer. And yeah, I'm writing code. I'm doing that for a long time. I probably will do that till the time I die. But in the last few years, like maybe 6, 7, maybe even more, I'm doing a lot of things in software automation, software delivery automation, helping companies to actually select architectures and automate things around them. So someone would actually call me a DevOps guy, even though I don't really like that thing. Okay, so yeah, developer, DevOps, person, trainer, speaker, co-organizer. I do a lot of things. But let's talk about this specific speech. What are we going to talk about? So how many of you actually used YAML? I guess everybody. And I guess most of you have used some sort of infrastructure as code tooling, right? I guess I did, right? So, and of course, different tools use different languages, but most of them kind of correlate on using YAML, and that's why I came up with this term called Yamlware, where basically any configuration infrastructure deployment as code tool is some sort of YAMLware. That's just a definition. Okay, and as you guessed, I guess from the title of the talk and from these definitions, that I'm going to talk about infrastructure as code and about what are the good things about that and what are probably the bad things about that. So, and basically this talk is like, it's a strategy in 2 acts, in part 1, part 2. In part 1, I'm gonna complain and whine about YAML, and in part 2, I'm gonna complain and whine about different tools. So it's a bit of whining, but I hope with some rationale behind that. Oh, so people are coming, great. So let's start with part 1, which is YAML. So YAML, is it good or bad? Who thinks it's good? Okay, 50%. Who think it's bad? Few people. Okay, so you actually like YAML. That's great, because there are the many things that you can like YAML for, but also the many things that actually you may dislike it for. And of course, YAML is great because it's just a data format, and if you read the definition from YAML.org, where the specification is coming from, you will see this nice definition, nice statement saying that YAML is a human-friendly data serialization standard for all programming languages. Nice promise, nice phrase. And of course, we as humans, we like something that is created for us, so it's human-friendly, at least it's supposed to be. The funny thing is that people have taken YAML very seriously, because every tool on planet pretty much supports YAML to some extent. And this started as a joke, but actually ended up being a real job advertisement. So companies are searching for senior YAML engineers. If you ever worked with infrastructure as code tools, with deployment pipelines, with anything related to infrastructure in general, you actually work with a lot of YAML, lots of YAML. And that's my daily job, like 90–80% of the time. And some companies really, take it seriously and hire senior YAML engineers. Funny, but true. On the other hand, YAML actually is, well, it's useful, absolutely, but it has some very bad things that are built into that. It's actually quite awful. Especially, if you try to use and actually abuse and overuse YAML for things that it was not designed for. Actually, if you just type on Twitter, on any search engine, you'll find a lot of people complaining about that, because there's just too much YAML in the industry at the moment. Also, people like YAML, like it's a great language, and you get a lot of errors while you're working with that. It's a simple language, but it's very hard to get it right, especially if you don't know what's behind that. Actually, if you search for this hashtag on Twitter, on Facebook, you will find a lot of people posting very bad things about YAML. So YAML became such a big frustration for the industry that there's even a hashtag for that. Actually, there's even a website called noyaml.com. You will find a lot of nice things about YAML there. For example, did you know that, well, YAML is a data serialization language, and you can actually serialize any object. And some of the parsers that exist out there, like Python or Ruby or Node.js, actually support deserializing different types of objects, like this one. What does it look like? It's a pure YAML injection. we inject code into YAML, and we get some, code execution that we didn't expect to. And this is actually still true for Python parser. And if you're using Python-based tools, you may, expect some peculiar results if you fit this YAML into them. Of course, it's largely fixed by now, but it was a problem at some point. Another thing is that, do you think it is possible to add duplicate keys in YAML? Who thinks it's possible? Well, some people think it's possible. Who thinks it's not possible? Yeah, and okay. Like 3 guys or 3 folks who said it's possible, 3 folks said it's impossible, others just don't care or don't know. And the thing is that according to specification, it must not be technically possible. But according to the real life, to the practice, different tools implemented differently. And I have spent so much time using different tools like Helm or Ansible, where actually duplicate keys caused me a lot of trouble. So I thought I was using one key, but actually it was another key coming from later in the code. And from specification perspective, it's not possible. From tool perspective, actually it is. Also, another thing that is a problem for many newcomers who start using YAML is the indentation. And I mean, in this case, we have 2 names. Which one of them is which, and which one of them is actually what kind of object it's trying to represent, what kind of attribute it's trying to represent. That's for newcomers. It's a problem because they may not know the model that the YAML is trying to depict here. And the more layers you have, the harder it is actually. Did you know this? That you can use colon in YAML to actually represent time values and angle values. Did you know that? No, but you actually can. And that's funny because if you ever used Docker and Docker Compose and maybe some other tools to actually do port mapping, then the string 25:25 will not map a port 25 to port 25. Actually, it will mean to YAML, to actually valid YAML parser, it will mean that it's 25 minutes, 25 seconds, which will be mapped into that number. You will be really surprised to see what's going out. Of course, in order to overcome this, you have to quote the string. Then you will get the proper behavior. But if you didn't know that, that's a gotcha. Actually, it's very well documented in the Docker Compose documentation. Same goes to 53. You will get this number instead. And you can actually have quite long numbers there. Just don't use colon by itself. Another thing. Did you know YAML actually supports anchors and references? Have you ever seen code like this in YAML? Who's seen this code? Or similar code? A few guys. I guess other people are not aware that this actually is possible. And it is. The only problem with that is that I personally, I know several programming languages. I'm a professional developer. This is an insult to me. This is very hard to understand, very hard to focus, and to parse in general. It's a nice feature if you have like few templates you want to work with, but I've seen people abusing this technique like crazy, and the code became very much unreadable. And the main reason to have this kind of structure in YAML is that you want to reduce duplication, but actually you reduce readability quite a lot with this one. Do you know how many values you can pass as a Boolean in YAML? Well, it's roughly 22, I think, 22 values. And the funny thing is that if you're living in Norway and you're trying to represent your domain name with no, and you don't put quotes around that, you will get actually a Boolean, you will get false. And that's one of the features YAML has built in. And of course, it's all English, it's all like yes, true, false, and anything. And of course, it doesn't support any other type of Booleans that you may potentially want to, because I mean, it was meant to be human-friendly, but for some reason, it only supports 22 values, but we want more, obviously. Another non-obvious feature of YAML is that, just think about it, you can take any YAML, you can cut it in any place, and it will still be a valid YAML. That means that if YAML data is transferred over the wire and at some point data is truncated, you will still get a valid YAML file. If you copy-pasted part of your YAML definition into Slack or email, and you forgot to copy part of that, it still will be a valid YAML. And the person on the other side will probably, scratch their head and not understand why their YAML is not working. So YAML is not, friendly for validation in that sense. You never know whether it's full YAML or not. Another one, I like this very much. YAML is not Turing complete. Do you agree? You think it's Turing complete? Seriously? I guess. Well, I mean, it's not fair, of course, because Turing complete is a feature of a programming language, it's a feature of a computational language, and YAML is a purely data language. You cannot use Turing completeness against YAML because it's not meant to be like that. It's just a data structure. But unfortunately, some tooling or some people were using YAML to actually, represent some data logic, some logic with some computational logic, and of course they struggle with making it Turing complete eventually. Okay, for example, Ansible. So, do you think JSON is better than YAML after this? No. Of course not, because it has no commands. In YAML, we at least can write commands, some sort of. Maybe XML is better? No? Yeah, not really. XML is a different language, and people were complaining about XML for a long time, then they got JSON. And then after that, they got YAML. And every format that we had, it actually has some problems. But let's stop whining about that. Let's stop complaining about that, and let's think about YAML as a tool. I mean, it's a data language. It's a data to serialize and transfer data. So of course, it doesn't need to be that advanced. And at the same time, we as an industry, we need some sort of serialization language that will allow us to declare the intent, to describe our configuration, to manage state, to share serialized data. We need this kind of language. And YAML kind of seems to fit that purpose and be the dominant one that is used to do that. On the other hand, industry is evolving. Industry is trying to create different formats like XML, YAML, JSON, and many others, and we create more. There's one called JSON NAT, which is kind of JSON YAML-ish kind of thing that, apart from normal data structures, also has additional structures for defining functions, variables, references, and all that stuff. And actually, you can generate YAML or JSON out of JSON NAT files, which could be quite handy, especially if you are a developer and you like using variables, you like using functions, you like using some sort of declarative logic that is more advanced than just plain data structures. And it's still, the cool thing about JSON NAT is that it's still declarative language. It's not a programming language, it's still a declaration of state, which is quite nice. Another one is JSON 5, and it's kind of slightly simpler than JSON NAT. And I like that, they try to emphasize that they willing that to be more humanish or more related to humans, even though it's not really that much better than JSON itself. Another language that is used quite often for configuration languages, for configuration data and configuration state, is TOML, which looks a bit like Windows ini file, if you have ever seen that. And it has some simple structures, some similar data structures, and probably could be used as a replacement if you don't like YAML as such or JSON as such. Another one that is kind of coming along is DHL, or actually I'm not sure how to pronounce that, but that's another language that allows you to define sort of YAML templates and JSON templates with the help of variables and functions and additional logic that you could put inside the language. That's nice. Another one, YTT, which is the Python-like language that again is like a YAML templating engine that allows you to generate stuff. And people are using that for Kubernetes templates and some other things. So if you are a developer and you are convinced that pure data structure that a YAML provides you is not enough, you can use templating language like YTT or DHL to actually generate YAML and have like proper variables, proper functions, proper, a better programming language inside that. Yeah, this is an example of YTT. It's a bit like that. Another language, which actually is not YAML, but it's kind of getting popularity as well, is HashiCorp configuration language. And if you ever use Terraform or console or something like that, actually has very similar structure, but again, it has functions, templates, and all the things built into the language, which allows it to generate either JSON or eventually YAML as well if you want that. This is an example of real HCL code, actually Terraform code. Okay, and if you really want to use a real programming language, there's another tool that came not so recently. Actually came recently out. It's called Pulumi. It's also it's not generic tool, but it's actually working for infrastructure as code, which allows you to use same abstractions, same kind of things you can use in other tools like Kubernetes or Terraform or similar, and express them using real programming languages like TypeScript or JavaScript or Python, for example. So if you are as me, like a developer, willing to get more power into how you express your state, your configuration, there are many options to do that. It's not just YAML or JSON. Okay, and of course, head explodes when you look at what are the options, and okay, I guess it's up to you to decide which one you're going to use. But don't invent a new one because people invented already enough. And the main goal for these languages is that we try to describe serialized data or declared state. And we usually, YAML doesn't support, YAML and JSON and low-level languages, they don't support variables, functions, and deep references. But you can use a higher-level language like HCL or YTT to actually get that. And that could be a way out from YAML, disaster. Okay, we came to part 2, which hopefully is more interesting. And that's about the machine, right? So as you probably know, there are many tools out there, like Terraform, Kubernetes, Ansible, Puppet, Chef, and they are quite different tools. At the same time, they share the same approach to how they manage information about the resources that we're trying to use to define with the languages that they use. So usually, we have a sort of declaration in those tools. Usually it's YAML, but it could be HCL, it could be JSON, it could be I don't know, some programming language that does that. But essentially, it's a declarative state, it's a declaration of things that we want to apply to the world, and we want the machine, the tool, to actually take that definition, take that declaration, and make the changes in the world for that definition to become true. That's the essence of most of infrastructure as code tools or provisioning tools. They want to make the declaration become true in the world that they manage. Of course, there are many components that usually involved in that. Some sort of parser, some sort of getting facts about the actual existing world, doing some mapping between the code and the facts, and actually creating a model of what we want to actually change, and then actually execute the set of actions that we need to make in order to make this true. Okay, and YAML or any similar language is just declaration of what we're doing, and heavy lifting of how, of what exactly the actions are going to be executed is done by the machine, by the machinery, by the tool. Okay. Yeah, let's look into fictional universe called Yamlware, and in that universe we have a tool called Universe State Engine. So it's a machine that manages the state of the universe, and of course it's a very fancy one. We want to use that. Of course, it uses YAML to describe the state of the universe. And they just released version 1.16 this month, and you can get that by using use version. Okay. And it works in a similar way that like many other infrastructure as code tools work. We give it a state described inside the YAML file, and the tool is taking care of applying that state to the target world, which in our case is going to be our solar system. Okay. Also, we have another like side project, side tool that is monitoring that stuff. So fast and breakable monitoring engine, which reports stuff. And we also have kind of Jenkins alternative in this world called Job Oversight Bot System, JOBS. Okay, let's play with that. Well, you know Pluto, right? Pluto is a planet. Or is it? Is it a planet? Okay, some people know it's not a planet. Actually, it is a dwarf planet, right? And this happened maybe like a few years ago. Astronomy the scientists decided that it's not a planet, it's a dwarf planet for some reasons, because it's not actually rotating in the same way as other planets rotating. So, I mean, we know that, we want to fix that information, and I mean, it doesn't change anything for Pluto. Pluto doesn't care about its status, but we do. And for us, it's actually just metadata, and we just go and update that. So we run apply on solar system, modifying Pluto, Pluto system metadata modified in 10 nanoseconds, very fast. And then, I hope you see that, few message now said that libraries on Earth have been updated to reflect changes in Pluto status. Nice, it worked. The tool works, the use engine works. Great. Okay, let's play with that further. I mean, we see that the engine works, and let's create an object that, in our understanding, is not doing any harm. Just let's create a comment. And we define it like that. We just say, okay, kind comment, metadata my comment, because naming is hard. And we say that the speed of that comment is 1,000 kilometers per second, and we just want one of them. No problem. So we use the same thing. We say, please apply the new state of solar system to the world, and and it does. It creates a comment. But then we get a strange message from Fume saying that, okay, something unknown approaching Earth. Something we didn't expect. Of course, we don't want that. We don't want Earth to be destroyed by a comet we just created. And we just remove that piece of code from solar system to YAML. But the problem is that use doesn't care. I mean, it says everything is up to date, have nothing to do. But the comet is still approaching. And this kind of things actually happens in many infrastructure as code tools. If you delete the code, from the definition, from YAML file, from JSON file, from whatever, the object that was created before is not removed. And that happens with the comment. You have to do some compensating actions in order for that comment to actually be removed. So we have to do use delete comment like explicitly. That's a surprise that comes to many people who start using this infrastructure as code tools. And in this case, the planet will be saved, hopefully. Okay, let's do something with Earth now. Let's define another moon, because we have one. One is not enough, like obviously. And let's add one more. Let's add moon 2. And again, because naming is hard, we just name it moon 2. So we use apply solar system. We define the new moon, and everything seems like it took some time for the engine to do that. But eventually, moon 2 is up and running. Nice. I mean, the engine works. We kind of just declare to say want a moon, and the moon is created. Cool. But of course, it's not coming because, I hope you can see this red. It's not really visible, is it? But basically, yeah, it says that we have some floods in Sri Lanka, and we have some, rotation is slowed down, and we have some regional risk of seasonal shift, which is not something we want to actually do. And in this case, because the object was actually part of the planet object, we just remove that line and apply it again, and after a while, the moon is removed and everything is back to normal. So in this case, the object was part of another object dependency, which actually was capable of handling. So when you work with infrastructure as code tools, you may end up having these both situations. Sometimes the engine may manage the objects and delete them accordingly. Sometimes you have to do some compensating actions to actually achieve the effect. Okay, let's have another one. Yeah, we know it's an old bug, right? Earth is overpopulated. We need to scale it up to house more people, or more biological forms, I would say. What do we do? Well, the smart idea that I had, at least, is that let's increase the radius of Earth. Let's make it 8,000 kilometers. And of course, you all know that Earth radius is 6,500 kilometers. We just make it 8, to make it bigger and have some more space on that. And okay, at this point we started to use a proper, CI/CD pipeline. Of course we keep all the code in Git. We made a change in our solar system YAML. We make a commit. We make a push, and because this repository with our solar system is attached to the pipeline, to CI/CD pipeline in jobs, jobs picked it up and started, applying stuff. So it picked up that commit, start running script, use apply solar system.yaml, and something strange is happening. It says destroying planet Earth. What the heck? And of course, we don't want that. It's not something we wanted. We wanted just to increase the radius. We didn't want to, destroy the planet and create a new one. We really wanted to just have a slight resize. And apparently, in some cases, some of the objects that state engine or state machine is managing, the only way to change some attributes of the object actually is to recreate that. And that happens with Terraform, that happens with Kubernetes sometimes. You have to be aware of that, of course. And we don't want Earth to be destroyed. So hopefully, and because the destruction is taking a lot of time, we actually managed to stop the job and roll back, and everything was fine. And of course, after this incident, we wanted to make a backup of our planet, and for some reason, our use engine actually started to support that. They introduced a new object called Planet Backup, and we decided, let's do that. Let's do a backup, and let's make it very often, like every minute. Of course, it didn't end up very well. Basically, few warned us that there's no space left in space, eventually. These kind of funny things, if you don't understand what the engine is doing and what kind of capability it has, you may end up having. And that's something I had actually in real life, of course, not with planets, but with real clusters and real servers. When I updated the base image of a cluster, and eventually the whole cluster was recreated instead of just updating the image, and we lost a bit of production time because of that. Things like that happen. And of course, real-life state engines, the state machines that exist out there, Kubernetes, Terraform, CloudFormation, Serverless Framework, Ansible, Puppet, Chef, actually many other engines that work in a similar way. They want to manage the state of the world in a way they do that, and they have common deficiencies, common things that work well, and some of them support different things. Sorry. And of course, you cannot really directly compare those tools. For example, Kubernetes and Terraform and Ansible, they manage completely different types of objects, but at the same time, they have quite the same approach to how they treat the code. And I'm going to look into some of them now. So the most important thing of any of these engines is idempotency. Do you know this word? Anyone? Okay, many of you know this. Great. And basically, the idempotency defines that we can repeat the same operation against the same or previous state, and we will always get the same result of that. So idempotent tools will not fail if the state is already the same, and will try to achieve that state if the state is not the same. Okay, just a simple example here. So this command, for example, this script is idempotent because apt-get by itself is idempotent. If nano is installed, it will do nothing. If nano is not installed, it will install nano. And it doesn't matter how many times we run this tool, in most of the cases it will end up with nano being installed and will not return any bad result if it's not installed or if it's already installed. For example, in this case, this script actually is not idempotent because, well, the first command is idempotent, but the second command is not, because if user doesn't exist, it will create one. But if user does exist, it will fail, and the whole script will fail. So the result of the script will be failure, even though the actual state was already achieved. And obviously, we can make this script idempotent as well by adding additional code into that script, verifying, okay, the user does exist, we don't need to do anything. Then this script will always succeed if the state that it describes is actually correct. Okay. And of course, if we have just to manage the fact of existence of this object, then it's of course, it's going to be a very simple script. But if we have to manage existence plus all the different attributes that these objects may have, like package and a user, this script, to keep this script idempotent, we'll have to have a lot of ifs inside. And that's not what we want, because we want more or less readable code. And of course, in that case, we want to use YAML or similar tool, similar language, to describe the state that we want to achieve. And then the tool will determine what kind of ifs and commands and actions you should execute behind the scenes. We want just the declaration. We don't want to know how it does that. And that's a reasonable thing. Yeah, readability is for the win. Also, idempotency gives us very nice feature that we can actually integrate that into pipelines, into CI/CD pipelines, and because we don't want the tool to fail if the state actually is correct. We want the tool to succeed and go on to the next stage of the pipeline. Another thing that is not quite obvious from the YAML definition, is that what we actually get is a resource graph. And some of these resources may depend on each other. Well, some tools don't care about that. For example, Ansible doesn't care about the dependencies between resources that much. But for example, Terraform does care a lot. And what that gives us is that when we have clusters of objects that are relatively independent, what we can do, we can actually do that, and we can make execution in parallel, and we also order the execution in the right order. So these clusters will actually, these clusters of objects can be configured in parallel threads, and making also the whole execution fast. So another thing that state engines, that state machines are doing, is that they're also managing attributes of each object that they're trying to configure. And when you use these different tools, you have to be aware that some of the attributes are write once. So you just write them once, and then you don't change. You cannot change them after that. Actually, Kubernetes is quite popular in that sense, because it only allows you to change certain amount of fields, but all the other fields are not changeable, which is quite annoying sometimes. The same thing happens in Terraform. The same thing happens in Ansible sometimes. If you don't know that this attribute is writable only once, then you may end up changing the attribute and not realizing that why state actually is not changing. Okay, sorry. Yeah, also sometimes attributes may require extra actions to take effect. So, for example, you have to change the attribute in some other way, doing some compensating action, but at the same time you have to change the code so they both are agreeing. Then the tool will work. Before that, it will actually will throw an error. Also, sometimes, like with Earth, some attributes of an object will force a recreation. And that's something you have to take care of before you actually do that, because otherwise you risk losing actual data. Or, well, in case of Earth, like losing actual population, which we don't want to. And sometimes, the very best attribute that you can have to manage inside this kind of state engines is the one that is actually updatable right away. Something that actually is without recreation, without any hassle, without any extra actions, actually will update the stuff and do any additional actions that are needed to make that attribute value actually true. Another thing that these state machines and engines they actually have in common is that they allow you to not just define the state in hard-coded values. You have an ability to use more advanced ways of referencing stuff. So, for example, when you define a state of your object, you can have a hard-coded value, of course. You can have a reference to another object in the same code base to have dependency on that object and have some value from that. You can have some sort of well-known built-in fact that is already predefined by the tool, so you can already query it automatically from the world and use it inside your object as an input value. And also, many of these tools also allow you to define custom facts or custom calculated values that you can also inject. And the more advanced is the tool, the more capabilities you have to actually define the state of your object. For example, Kubernetes is very dumb in that way because you can only more or less configure the hard-coded values, and that's it. For example, in Terraform or to some extent in Ansible, you can actually query information about what things already exist, what things exist in my code, define additional stuff inside as custom facts, so they're calculated and injected into your code with a simple value, and that's a much more powerful thing. Okay. An example of data query inside a simple YAML file. Some facts are calculated, some facts are referenced, some facts are custom things. Also, another thing that, as I already mentioned with the comment, some of the tools support resource deletion when you remove the code. Some of them don't. Actually, most of them don't support that. Terraform, for example, is one of the tools I know that actually supports that. So, for example, if you have a definition without code commented out before, and then you commented out the code, then the package will actually be uninstalled. In case of a proper tool. Some tools will just keep it there. Basically, by removing code from this file, some tools will treat it as that I don't care about the state of this object anymore, so I will not delete it because I don't know that it should be there. And that's how Ansible treats that. That's how Kubernetes actually also does that. That's sometimes comes as a surprise to people who start using those tools. Also, yeah, you have to be careful with the resource recreation. Some tools will try to be very smart, especially Terraform does that from time to time. And when there's a certain attribute change, they will actually help us and recreate the object to achieve the state that we want, but that could be a dangerous thing that will result in data loss, for example. Also, to kind of, for example, in case of Terraform, it supports sort of resource protection, so you can say that this resource must not be deleted, whatever the tool is deciding. And if there's a need to recreate the resource or delete the resource, actually the tool will actually not allow you to do that. Another nice thing about this, most of these tools, actually, they support this. You can actually verify before you run anything, before you try to apply your new state, your new shiny state to the world, you can make a dry run to verify what are the actions that are going to be executed. And if you see any destroy or delete or recreation, you may stop that and maybe do some other actions to compensate for data loss or something like that, or actually make your change differently. Also, another thing that these tools are kind of doing is they kind of, not just installing stuff, not just you're not running them once, you're actually running them many times. And it's not just, state definition on one code, also state verification in that sense. So you can run the tool as many times as you want, and it will try to verify that state that is described in the code actually is true. And there are two ways of looking at that state verification. One is deployment time, and most of the tools that exist out there, like Terraform and Ansible, they actually are deployment time tools. The only time when you actually check for the state is when you run the tool, when you run Terraform Apply or Ansible Playbook or something like that. But also, on the other hand, there are ways to do the same thing at runtime. For example, Kubernetes does that, or if you use Puppet Master Puppet Agent, it also does it in the same way. Or if you use Ansible Tower, it's kind of also the same thing. Basically, you share the data about how the world should be with the master component, that is kind of with the controller, which is periodically verifies that the state that is defined in my data model of the world is actually correct. And in this case, it's actually trying to keep the state as correct as possible during the whole runtime of that engine. And that could be like forever. Both models are fine. Both models are good. Just depends on what kind of things you want to actually do. Okay. Another additional goodies you can have with these kind of different tools is, modularity, how they support that. Usually tools like, they have some sort of module hubs or public repositories of components or reusable bits of that software, reusable YAML code in some sort, where you can get something created by other people, which is kind of nice. Also, another thing I always look into when I'm starting using a new tool. What is the state of the documentation? And if it's not very good, then of course, most likely I will not use that tool at all. Okay, and what I kind of tried to do is that I defined this kind of state machine index describing what is the maturity of different types of components that compose that engine, the state machine. And one of them is idempotent maturity, so how probable it is that the result of our execution actually is idempotent. What is the language level, declarativeness maturity, readability of that code, how much we can actually query about the world and about the other pieces of the code. What is the execution engine maturity? Does it support parallel execution? Does it do auto ordering? Does it support deletion of obsolete object that was removed from the code? And also another one is modularity maturity and documentation maturity. And I tried to put it into a single index. These are the tools I use the most. Of course, I use other tools, but these are like the ones I know the most. And I put it on a single matrix, defining what are different, level of maturity for different parts of these components. And this is what I got. And honestly, Ansible in that case, it looks a bit, shy, because it doesn't support a lot of things that a state machine can actually support. Kubernetes and Terraform are kind of better in that case. And for example, Terraform is the only tool I know that supports object deletion. If you remove the object from the code, it will be actually removed from actual world, which is quite great. Kubernetes doesn't do that, and Kubernetes, for example, doesn't have built-in support for modularity. You have to use some other tools for that, like Helm, for example. Ansible and Terraform actually does support that, which is quite nice. But again, my main point here is that, of course, different tools probably these tools are not comparable from the perspective of what they're doing, what kind of objects they're trying to manage, but they are definitely comparable from state machine point of view, and that's what I try to do in this simple matrix. So looking at Ansible machine is that, yeah, it's quite simple. We have an Ansible tool running the code, and it's usually running them against the servers, unless you use some sort of Ansible tower instead. But in simple case, it's just connecting directly over SSH to the servers and managing what is on those servers. So it has some signs of state management. So it has some attributes you can manage for different components like users, packages, services, and all that stuff. But the idempotency level is not always achievable. Unfortunately, parallel execution is not fully supported by Ansible. So you can definitely run the same playbook or the same code against the different machines, but on the same machine, it is impossible to run it like in parallel because Ansible doesn't have notion of resource clusters, resource dependencies in general. And also, any imperative logic and any kind of logic that defines the relation between different tasks is very hard to express. And if you ever used Ant, I hope we have many Java developers here. If you ever used Ant, well, Ansible at some point starts to look like a very complex Ant script, which is not a good thing. Kubernetes machine is quite different because it's the one that, by definition, supports the runtime verification of the components. So basically, what you do with your Kubernetes code, you send it directly to the API server, which is the master component of Kubernetes, and it stores that data inside a database called etcd. And then it's the responsibility of controller and kubelets to actually achieve the state defined in the etcd on the whole cluster. So in that sense, Kubernetes is it's an engine that when you run code against that, it will be successful if the code is valid, but it will not tell you if the state that you described actually describes a state, an achievable state, because that's what Kubernetes will try to do at runtime, and then you have to actually use some monitoring system to actually verify that the state was applied eventually. And it may never apply. Kubernetes doesn't guarantee that it will apply. Eventually it should, and Kubernetes will try to do it as much as it can, but you will not get as a result of the kubectl apply tool. So yeah, it will just accept any valid object definition. Will it be created and will be running? Well, if the resources permit that, it will. If not, then you will have to go and monitor and do something about it. It will actually do runtime state validation. So if something happened to the cluster, like one node died or one pod was, doesn't have enough resources, Kubernetes will actually, at runtime, will try to achieve the state described already in the etcd database. And if it can, it will. If it can't, obviously you will not be able to do that. So it's runtime state validation. And not all attributes are changeable. So if you have a persistent volume attached to a stateful set and you want to change the size of that, good luck. Well, you can do that, but only with latest versions and with some extra compensating actions. Not everything is possible, at least not yet. And also, object deletion is not supported, and that's something that Kubernetes team is actually trying to achieve in next versions. Maybe like in a year or two, we will get that functionality. Also, another thing's maybe not that important. Okay, I'll skip that thing. Terraform machine is another one that is kind of similar to what Ansible does, but the only thing it actually has is a separate storage where it actually stores information about the previous state of execution. So this gives it an ability to actually delete the objects if they were removed from the code. That's actually a nice feature because then your code would actually describe the exact state you want to achieve, and nothing else, nothing that is lacking will stay behind. So no traces will stay behind unless you really want that. And it has a lot of data query capabilities and powerful ability to describe different abstractions that are not possible if you use a simple language like YAML. Okay, final words from me. Tools, all these state machines, when you look at them, they look very nice in the documentation. They look very nice in the tutorials when they describe, okay, you change the attributes and then magically changes the whole object without much hassle. But unfortunately, it's not always true, because some attributes are not changeable, some attributes are changeable right ones. Some attributes will actually recreate the resource. Some attributes will actually work fine. You have to know the tool. That's now the way. You have to know most of the side effects that could happen there. You have to know them. That's no other way. Also, the good thing is that there are tools for tools. So there are different types of linters, IDE plugins, schema validators that allow you to actually verify the code before you run it against the real production. Maybe you can test it in different environment. Maybe you can verify the quality of the code, and all that stuff will give you some warnings before you apply that and destroy some clusters. And one plugin that I use at the moment, for at least for YAML files, is called Rainbow Indent. Basically, it shows me how much indented is my code, and because I know the model of the tool that I'm using, that I'm configuring, it usually allows me to color code things that are on different levels. That's kind of handy at least for me. Also, another thing that YAML is not good or not bad; it's a tool. Also, different tools like Ansible, Chef, Puppet, Terraform, Kubernetes, Helm, they're not good or not bad. They were designed for some sort of thing, and usually, if you want to define your attitude, your relationship with the tool language, you have to make it like on a spectrum level. So some things are good, some things are bad, some things are not as nice as they could be. And for that reason, I defined that matrix that kind of allows me to understand what kind of relationship I have with all those tools, even though I used all of them quite professionally every day. Also, if the logic of your infrastructure's code is getting very complex, maybe you're using the wrong tool. Maybe you should use a programming language for that. Maybe you should use a better declarative language for that. And I've seen a lot of crazy Ansible playbooks that just impossible to understand. They do the job, but they're impossible to understand. So maybe Ansible is not the good tool for that. I've seen also quite hard-coded, quite crazy Terraform playbook, or modules, Terraform code. And again, maybe it's not the one that you want. Maybe there's another tool that can be used for that. Also, I've seen a lot of custom code that people were generating Kubernetes descriptors. Maybe, again, it's not the right tool for the job. Maybe you need to use something else. Maybe you have to use Helm. Maybe you have to use some sort of write your own operator for that. That's always a question. But keep it sane. If your code is becoming crazy, it's not the fault of the tool. It's your fault, obviously. Okay, keep it simple. And I guess, thank you.